Alrighty, we are now at 3 after, so we can go ahead and get started. I'd like to welcome everyone again to the NAIRR Pilot Partner Series. We have ML Commons Croissant here today giving a presentation. As always, this presentation is going to be about 45 minutes, and as always, we will have a 15-minute Q&A at the end of the session. So during the course of this presentation, if anyone has questions, please feel free to use that Q&A tool at the bottom in Zoom, and we will answer questions from the Q&A tool at the end of the presentation. This session is going to be recorded, so if you'd like to go back and rewatch, the video should be posted to the NAIRR Pilot YouTube channel within about the next 2 weeks. And today's presenter, we have Elena here. Hi, thank you so much for joining us.
Hello.
And I will go ahead and pass the presentation to you. Please feel free to share your screen. And I look forward to it. Thank you so much.
Okay. Well, thank you so much for having me. Everyone should slowly see my slides. Yeah, do the slides look okay? Could someone give me a thumb up, thumb up,
Perfect.
something like that? All right, good. Lovely. So, my name is Elena Simperl. I am based at King's College in London in the UK. Where I lead the King's Institute for Artificial Intelligence. I'm also director of research at a nonprofit called the Open Data Institute. The logo is here on the slide, which has been set up 13 years ago by Tim Berners-Lee and Nigel Chatbold, with the mission to build a better data ecosystem. And a very interesting and valuable data ecosystem that is emerging over the past years is around AI use cases. This presentation talks about work that we have done in the ML Commons community group, working group that is developing Croissant, which is a machine-readable metadata format for AI-ready datasets. I'm co-chairing that working group with my colleague Omar Benjamin, who is based at Google, and there's many other organizations contributing. I'm going to talk about this in a short while. Okay, but let me just quickly give you an introduction to ML Commons. ML Commons is a members-based association. It's a non-profit with the aim to build industry standard measurement and data tools to have a healthier, safer AI ecosystem. In terms of activities, they're all community and member-led. There's a lot of work in the area of benchmarks and benchmarking tools for AI. There's work on creating critical missing datasets. There is the Croissant dataset vocabulary, which I'm going to talk about in this presentation. There's work around benchmarking for medical AI use cases. And there is a lot of work around AI risk and reliability, including the AI Illuminate work that has been released in the last 18 months with a number of valuable resources, including benchmark data sets and tests and protocols to test the reliability and safety of chatbots. As I was saying, this is a community driven by more than 125 members and affiliates. Those of you who are interested in joining, individuals can join at no cost, and most working groups across those 4-5 areas I have mentioned on the previous slide are accessible to everyone. Institutions can join as members or affiliates as well, and there's information on the ML Commons website. if this is of interest to you. I've already mentioned the focus areas. I think what's also perhaps interesting is some of the level of activity that we have had since 2018 when the organization was set up. So more than 10 different benchmark suites for different software and hardware architecture, almost 90,000 measurements. So those are teams that are benchmarking their AI solutions according to these community agreed shared benchmarks and are publishing the results, leading to a more evidence-based, I would say, understanding of technical and safety progress across the ecosystem. And the 700,000 KPI is related to Croissant. This is already a bit out of date. So we have more than 800,000 by now machine learning and AI data sets that are described with the Croissant metadata format. The area I am working in ML Commons is what I call data-centric AI. What is data-centric AI? Well, data is a term that was introduced, I think, many years ago by Andrew Ng at Google at the time to emphasize the importance of data alongside algorithms for AI performance as well as reliability. The way we like to tell the story in ML Commons Croissant is that we're facing a new barrier. While we've seen astonishing AI advances over the past 3 years, there's also an understanding that as foundational models are fueling new products and services, for these products and services to deliver added value and improve our lives and our work safely, we need to be able to pass that reliability and safety barrier. This is a slide that Peter Madsen, the president of ML Commons, usually uses to present data-centric AI. And I find this analogy to the aviation sector quite compelling. So if you think about the history of AI since the 40s or the 50s, there were lots of ideas for decades that were very compelling academically, but never quite worked, either because we didn't have enough computational power or not enough data, or maybe not as many ideas or people interested in it. In the last years, amazing research, but also a lot of hype and misinformation across various communities and in the media about what AI can and cannot do, or should or shouldn't do. Sort of reminiscent of late or early 20th century when planes were starting to fuel people's imagination, but we did have a sketchy understanding of how to make them safe, to right now where we're talking about agents and we see AI and generative AI in particular embedded in our office productivity tools, in our search engines and many other technologies we use every day, with the need to have a much better understanding of reliability and safety. And now part of that journey to build AI in a reliable and safe way is not just to develop new evaluation protocols, but also to have better both testing and training data. Because as far as we are concerned, those tests are the equivalent of software design, and data is essentially the implementation. So we're moving from model where there was a lot of focus on machine learning modeling and benchmarks, to a model where the behavior of a system is very much driven and influenced by new data sets, by new methods to understand the quality and fitness of use of those data sets, which then informs the development of data-centric reliability and safety benchmarks. So that all sounds great, but lots of the components that would make a robust, comprehensive AI data infrastructure for AI reliability and safety are missing. So if I continue with that analogy around design and code, so for conventional code, we have tools, we have best practices to support key activities from designing an architecture, the languages that we're using, editors, and other types of capabilities that form the standard development toolkit. We know how to build unit tests. We know how to interrogate a piece of code that doesn't work. Say all this environment needs now to be built for the data that we are using to make AI models and systems more reliable and safer for everyone. Now, when you talk to infrastructure, infrastructure works better with standard formats, and probably I'm here with an audience that knows this much better than me. Now, if we're thinking about standardization in AI data, well, machine learning data sets today are pretty much like snowflakes. So they're uniquely structured. There's a lot of, I would say, artisanal work in how they are created. There's a lot of mixing and matching. They're processed using different tools and different platforms. So there is friction. Data portability is still very, very low, which means that if we're thinking about the global infrastructure to be able to ensure that our AI products and services are gonna be delivered to their customers and be safe and trusted, we need to think about how we would make these different components of this infrastructure interoperate. However, at the moment, we have machine learning data sets and tools that don't work in that way, and they have to deal with challenges like the heterogeneity of the data. So you have both unstructured and structured data in the same sort of data distribution. Now, once that data is processed to feed into a machine learning model, there is some flattening and denormalization going on. You have a whole range of attributes or information that is needed for specific machine learning tasks, whether that's technical tasks or responsible AI. And then if you want to build reproducible pipeline and to support machine learning operations, then there's questions like around versioning, checkpointing, and so on and so forth. So these are the types of concerns that motivated us to start the work on Croissant, which is an open, extensible format for machine learning datasets based on web standards. So technologies that have been used to publish data on the web to support a wide range of use cases and consumption patterns for that data. Croissant represents machine learning data and metadata, so information about the machine learning data set. And the aim is to reduce friction for using data sets across different types of machine learning tools, to make it easier to publish, discover, and reuse machine learning data sets. And as I briefly mentioned, to support responsible data practices that are emerging. And on the right-hand side, you have an overview of the types of data flows and activities that we're supporting. And I think on the next slides, I have a few more details about data publishing and use, as well as interoperability between data repositories, which has emerged as one of the key use cases as well in data discovery for us. The story so far has been that we've launched version 1 of Croissant in March 2024. We were absolutely overwhelmed with the response. By now, we have, I was saying the 700,000 number is slightly outdated by now. We have a number of repositories that hold hundreds of thousands of data sets already supporting this technology. This includes Hugging Face, Kaggle, OpenML, and others. And we have some tooling that support both publishing and use. And this is a continued development. So if you're interested in joining us, we are working towards version 1.1. I'm going to tell you a little bit more about the new features to expect. But before that, let me just tell you, you would be joining a very friendly and informed and diverse community of researchers and practitioners from different areas. So this is a snapshot of the institutions that are participating in the Croissant working group. So the logos are of those institutions that have contributed to the version 1.0 specification, so the release from March last year. But we have new developers and teams joining almost on a weekly basis. And they may come from the machine learning space, so machine learning engineers who want to implement more efficient data workflows. But we also have folks with a background in data management who are now thinking about AI use cases for their data. We have responsible AI researchers who are looking at means to build assistance or automated support for technical governance, for instance. We have people who are engineers building data repositories. We have people with a policy background as well, and from various domains, from geospatial data, health data, government data, statistical data. So it's quite an exciting space to be, and I feel very privileged to be one of the co-chairs of the group. I should also say at this stage that we also have subgroups and projects that are meeting separately and report back to the working group. We have a GeoCroissant extension, which is going to be released this year. We are discussing setting up a health extension as well. And then we have a number of projects that are looking at specific technical concerns. So let me tell you a little bit about what's within this vocabulary. So this is a JSON-based format. So it's a machine-readable description of a data set with a number of attributes. There's 4 layers, so 4 categories of information that you would find in a JSON file that describes a machine learning data set. There's general metadata, so general information about the data set with a few machine learning specific attributes. So many of the attributes that we are using to capture general information come from schema.org dataset. So schema.org is a community standard for a markup language to describe websites, which then helps crawlers and indexers and search engine understand those web pages and provide more accurate results. Schema.org is an extensible vocabulary. So within schema.org, there is a specific schema for data sets that you can describe, for instance, a set of CSV files in terms of general attributes like the name of the data set, the license that is used to reuse it, brief description. Now for machine learning data sets, we have extended schema.org data set with attributes like splits and features and labels, which machine learning engineers are interested in, as well as a number of responsible AI attributes. Then at the next layer, we have so-called resources attributes. So these are two types. One are file objects. So those are single files like CSV, JSON, zip files, and so on. Or we have directories or sets of files of the same modality. So like a directory with images, a directory of text files. In addition to this, we're also supporting attributes that help a loader, so a tool that is loading this data, for instance, to train a machine learning model, to understand the structure of the resources, of the files and sets of files. We support using JSON paths and regular expressions, a little bit of data manipulation, as well as some machine learning specific data interpretations for interoperability, like bounding boxes and ways to organize the data in the traditional train and test split, for instance. Everything that you want to know about Croissant is available in our repository on GitHub, which you can have access to once you have registered to join the Croissant working group via the website, and registration is free. So we have the general metadata. We have we capture the different types of files, and then we also have a bit of semantic. On one hand, from a structural point of view, so that tabular structure with the different fields in the data, which also means that we can do some joining and flattening of the data in preparation for loading. And then we have the custom types like bounding boxes and train and test splits that are explicitly documented in the metadata. This is an example. I'm going to go through this only very briefly, but we have many other examples in our Git repository, and as well as in the specification document. So this is an image data set. So the basic metadata, as I said, based on schema.org data set, has these attributes, the type, the language, the name of the data set, where you can find the data set, the description, and the license. Then we have a Croissant attribute here where we're pointing to a NAIRR publication where this data set was described. We have then, if we're moving to resources, so those were file objects, so single files or sets of files or directories. So here we have a distribution JSON object, and within this distribution, we basically have a link to the past metadata CSV file and a hash. We have a predefined list of encoding formats. And then if we have a set of files, basically, then again, you specify an identifier. You say it is a file set, so it's multiple files. And then the source is a set of file objects, like in the example on the left-hand side. Now, if we're talking about capturing a little bit more about what's in that data, so we know it is a CSV file or a set of CSV files, for instance, or a set of images like in PASS, then we create this record set object where we basically describe with CR Croissant field the different types of information that you could expect there. Okay, so let me just explain a little bit more how Croissant can be useful both for a developer wanting to use a data set or for someone who's looking to publish their data to make it available to machine learning developers. with a data set that has a Croissant metadata file linked to it, your dataset will then be indexed by Google Dataset Search, which is the biggest online dataset search there is. So that means that you can go now to Google Dataset Search and you can filter by Croissant as a metadata format, and you will receive that information. Equally, when you look for machine learning datasets, you will also have access to the Croissant record if you want to do any type of analysis of machine learning datasets more broadly. You can also download machine learning datasets from a range of repositories. So I've mentioned Hugging Face and Kaggle. There's OpenML, there's TensorFlow dataset, there's CCAN and Socrata. So these are data platforms that are typically used, for instance, for enterprise data catalogs or for government data portals. Dataverse is a data platform that is used for various types of scientific data sets. Is an open source project, I think, led by Harvard. So all these repositories where you find AI or machine learning data now also have Croissant metadata linked to them. That also means that now we have a way to exchange information about data sets contained across these different repositories. So a Dataverse instance say, digital humanities data or history data can communicate with Kaggle and the data sets they contain. Then, if you have found a data set, Croissant also facilitates data portability. So you can load that data in TensorFlow and PyTorch without any modification. If you're a publisher, and some of us who work in AI are, either because for specific tasks there just isn't a data set that allows us to judge how well the technology performs, or because we have data that we want to share and make accessible for various purposes, including AI, we have a number of tools to support it. We have I would say, very basic visual editor, which essentially allows one to specify the values for the different attributes with a little bit of automation to make sure that what can be filled in automatically is extracted from other documentation sources. We also have a Python library, and meanwhile also a library in Rust and I think Go and a few other programming languages to perform basic operations on Croissant metadata records. So we're talking about validation, we're talking about creating a Croissant record or storing it. We also have tools for large language models to read ML datasets and the Croissant metadata. So this is a very new project in the working group, which is led by the OpenML team at the Technical University in Eindhoven in the Netherlands. They call it Eclair. So we're staying with the pastries theme. It is a model context protocol server. So model context protocol is a way to standardize how AI agents or LLMs access data and tools. So the Eclair server essentially allows one to search for a Croissant-enabled data, so a Croissant-described data set, to inspect both data and the metadata, and also to do some essential data exploration. So to answer user questions, generate visualizations and other types of analysis, basically. So the front end looks like in this, or should look because it is still very much work in progress, like this window here on the left-hand side, where the LLM is searching for relevant data sets and is essentially automating, supporting the user who is issuing this data request. In green, what is the most common tree at 3,000 meters elevation in the US. So then the LLM is looking for data sets. And because we have Croissant and because we have this MCP server implementation, we have an architecture, general architecture that we can deploy to do that. We don't actually have to write custom code to interrogate specific repositories where the data may be located. So it supports discovery, provides some information that it reads from the Croissant file, and then the user says could, for instance, ask for a visualization, which means that we need to write code and execute it to generate the visualization, or it could ask various other types of data tasks without the user having any specialist coding skills. Right, so I've talked about responsible AI practices. So we see Croissant as a way to operationalize essential responsible AI work to support responsible AI researchers or policymakers on specific use cases. Responsible AI remains very, very important, but we also know that it requires a lot of resources, which carry a cost for every organization, but carry a substantial cost for smaller players, for instance, startups in the AI space. So some degree of, we're thinking about some degree of automation and how Croissant could enable that. There's also a case to be made around the need to have standardized formats, and including machine readable formats, for instance, model data audit cards, to carry out essential analysis. Equally, established practices like fairness and fair data access cannot be carried out with documentation formats like data cards, which are primarily meant for human consumption. Say within the Croissant working group, we have a project specializing on responsible AI, and we have these 6 use cases. On the one hand, we recognize data governance as something really, really important, and we want to capture key milestones in that data lifecycle. We'd like to have more information about the human in the loop. And by that, we don't necessarily mean the end user of a chatbot, but we do mean the data workers that are performing essential labeling and other types of curation during the life cycle. Reliability and risk and safety, including fairness. I've already mentioned this as the motivation for the data-centric AI work. And then in Europe and other parts of the world, there's also more and more work on regulation. For instance, in Europe, there's standardized templates that the EU AI office has defined for reporting essential information about models and data for general purpose or for foundational models that are used in high risk use cases. That's a little bit more information. We have presented Croissant at NeurIPS last year. We have a very close relationship to NeurIPS as a whole. So this year, those of you who might have submitted or considered to submit in the datasets and benchmarks track might have noticed that Croissant is now a requirement for everyone who submits datasets. And the reason for this is because the NeurIPS team see Croissant as a way to enable a more transparent review process where the reviewer looks not just at considers not just the paper that you also submit, but also essential information about the data set that that paper describes. So we have now several thousands, a corpus of several thousands of such data sets and the papers, and the support in the open review platform to publish new Croissant records. We've also, with my team at the Open Data Institute, published extensively about how Croissant could support specific responsible AI concerns, whether that's the open source principles of the new open source initiative definition of open source AI, whether that means fairness as in findable, accessible, interoperable, reusable data principles, or in fact, regulatory initiatives like the European AI Office Code of Practice, in which we were involved at the beginning of this year. So if anyone's interested, on the Canvas is a Medium channel of the Open Data Institute where we publish some of these thought leadership pieces regularly, as well as the Open Data Institute website, where we provide summaries of all the responses and other types of interactions with policymakers, mostly in the UK and Europe, but also increasingly more globally. So I've mentioned Croissant version 1.1. This is very much now been the focus of 2025. We have received a lot of feedback from a number of organizations that are using or considering to use Croissant in various sectors, whether that's finances or official statistics or health, agriculture, from all over the world. And we've collected these use cases for and prioritized them for this version 1.1 release, which will be this year. One of the things users have told us over and over again is that they would like more information about the provenance of a machine learning data set, and the lineage of that data, so the way it was created. Especially from the responsible AI community, we have heard many requests to support not just metadata at the level of a data set, but at a more granular scale. So within a data set, they would want to be able to say, for instance, for safety testing, they would want to be able to say how a particular record or subset of that data has been created or has been labeled. There were requests to have richer machine learning data, metadata, so not just train and test splits and things like that, but a number of other attributes that are supported in data cards, for instance, on Hugging Face or Kaggle, that developers tend to use when they search. Support for multilinguality, as well as more semantic and linked data formats that would allow one to reuse existing metadata vocabularies. For instance, in the Responsible AI Working Group, we're looking at settings where the Croissant metadata will be the only public record of a data set. The data itself cannot be shared because it is sensitive or contains personal information or is sensitive in a different way. So in those cases, we're looking at a ontology called the data use ontology. We're looking at standards like open data rights language. I think the name is ODRL. There's a number of domain-specific vocabularies that we need to consider. So we are going to have a mechanism to be able to reuse attributes from those vocabularies in Croissant as well. And with that, I think I'm more or less on time. I'd like to close by thanking the entire working group. He's been contributing, showing up every Wednesday, presenting their own ideas, contributing to the different sub-projects, new features, building Croissant support across these different software platforms. The working group is free for everyone to join via the Croissant website. There's a little screenshot here on the slide. And we meet every Wednesday at 5 p.m. UK time. So that's an hour earlier than this webinar today on a Wednesday and on a Thursday. Thank you very much for your attention. And I'd be very happy to take any questions.
Thank you so much for your presentation, Elena. We do have one question already out the gate. The question is there any Croissant training certification? And if not, is Croissant training a certification or a badge on the roadmap?
That's very interesting. So we'd love to have that. We'd love to have that. Fact is, we've been focusing so much on implementing what's on the product roadmap, and we still feel that we are at a time when there will be additional releases. So our priority at this stage is to reach a stable product and improve the documentation we have for developers about using it. But this would be a great idea for a next step.
Fantastic. Thank you so much. Another question we have is, does Croissant support linking data sets to the models they were used to train?
Very good question. Indirectly, I would say. So there is a sub-project, or there's a project we have at the moment to define more machine learning related attributes. One of them is machine learning tasks. The other one would be a way to identify machine learning models, which we hope to have ready for the version 1.1 release. But if you're interested in that, do get in touch, and I can put you in touch with Omar and a few other people in the group who are working on those attributes right now.
Thank you. We've got another question in. The question is, I understand that Hugging Face's dataset viewer automatically generates Croissant formatted metadata. Is this the only available automation for Croissant description generation?
No, there's Kaggle is generating this as well. There's a number of other data repository software that would do that for you. So Dataverse would be another example. The OpenML data repository as well. So depending on what your repository of choice is, then you would have these capabilities. If you want to generate the metadata automatically, we have a Python library to help you with that. Though for some attributes, there would still be some manual input needed. The reason why Hugging Face is able to do that is because they use the existing data cards as a starting point to generate the values for the different JSON fields. At the same time, there is a project we have in the working group that is looking at using large language models to provide more automation. And we're looking for, so this is why, for instance, this NAIRR partnership we have is quite interesting, because we have a corpus of data sets and papers as well that we could work with. But it is something that some people in the community have been actively working on.
Thank you. We have another, it's a follow-up question on the linking data to models. Do you also plan to support metadata fields for tracking performance metrics from the model tracking services like MLflow?
Ooh, yeah. Very good question. So we get a little bit of this. It's not on the roadmap for 1.1, but it is. So it's been coming up quite a lot. So I would very much see us working on that in 2026. There's also some work that we want to do to support benchmarking, given also that ML Commons has a long history and expertise in that space. But it's something that I would, as I said, I would expect coming up in the next version for sure.
Okay. Thank you so very much. There are no other questions coming in right now.
That's okay. If people want to get in touch, say if you join the working group, there's lots of people who come to the Git repository and ask questions there or raise issues. We have a users mailing list as well if you're interested more in that side of things rather than getting involved as a contributor. But as I was saying a bit earlier, it is a lovely community to be part of, and there's people with so many different backgrounds, including some that work in research infrastructure, including machine learning engineers, including managers of data repositories. So it's quite a nice space to also just keep in touch with where our thinking is in this space.
Fantastic. We have another question posted in the chat.
Yes.
How does Croissant handle augmenting or filtering data with indications of quality of elements?
We don't have anything like that. There were some plans to do it. We haven't included in the version 1.1 release. I think the plan at the moment is to reuse an existing vocabulary. So if I remember correctly, there are related vocabularies in this that are doing very similar things. There is an extension of the DCAT vocabulary called MLDCAT that is providing a proposal for how to code that, among others. So it's I think at the moment or after the 1.1 release, the best option for that would be to import one of those vocabularies.
Perfect. Awesome. Well, again, thank you so much, Elena. And thank you everyone as well for attending today. We tend to try and have these webinars once or twice every month. So if you are interested in attending more of these webinars, please join us. You can find information for these webinars on the NAIRR Pilot website, on the Access website, and through our newsletters as well. We are really excited to continue sharing these with you moving forward. So if you are interested in, we have another question.
Yes, there you go.
Here's
let me
question.
open the chat because so there's images data set for an AI experiment. What is the best way to document and have a DOI for this data set published to other research? Okay, very interesting. You could use something like Hugging Face. I don't know if Hugging Face supports DOIs. DOIs are typically supported in platforms that for scientific data management. So if you're thinking about Figshare, if you're thinking about DataSite, if you're thinking about Zenodo in Europe, you have an identifier for that. There you go. Thank you. It does support DOIs. And they have a partnership with datasets. Thank you. I've learned something today. So that's the mechanism to do it. You upload it, say on Hugging Face, they have datasite DOI, and then you document it. They will ask you to fill out some information, so-called data card, and generate then with the Croissant metadata as well. So that means then you have that Croissant metadata, then a tool like Google Dataset Search will pick it up. Any Eclair MCP server and AI agents would be able to access that data if you build those sort of products and so on and so forth.
Fantastic. Okie
Okay.
dokie. If there are no other questions, everyone is welcome to submit questions as well after the webinar. You're welcome to email them in.
Yeah,
And you can find this webinar and all of the others on the NAIRR Pilot YouTube channel with the QR code on the screen. Elena, again, thank you so much for coming to give a talk today. We really, really
no
appreciate it.
problem. No problem. Thank you. And thank you very much for having me. Bye-bye.
Have a good one. Thank you so much.
Bye.